Hi everyone. So our group presentation is going to be on the subject of projectile motion. The book definition of projectile motion is that it is a form of motion experienced by an object or particle that is thrown near the Earth's surface and moves along a curved path under the action of gravity only. Our definition that we came up with for projectile motion is that it is a predictable path traveled by an object that is influenced by the initial launch speed, launch angle, and the acceleration due to gravity, or as long as it is in the air, it is considered a projectile. The exact definition of projectile motion is a form of motion experienced by an object or particle that is thrown near the Earth's surface and moves along a curved path under the action of gravity only. The effects of air resistance are assumed to be negligible. However, to simplify this, a projectile is an object thrown into the air that tends to follow a parabolic path. When considering projectile motion, there are three main components: initial velocity, projectile height, and projectile angle. The projectile height is the vertical height at which the object begins its trajectory, and the initial velocity is the rate at which the object is initially thrown or dropped. The initial velocity can be split up into two different components, horizontal and vertical. This is where projection angle becomes important. By utilizing trigonometry values of cosine and sine, you can determine the initial velocities in both horizontal and vertical directions. This is important because the parabola itself can be split into up and down components, in addition to the horizontal distance or range. After determining the individual initial velocity components, the uniform acceleration equations can be used to determine various other values. To demonstrate how initial velocity, height, and angle can have an impact on various projectile motions, we filmed the following videos.
As you saw in the video, our miniature assistant was able to make a few more shots after a brief explanation of projectile motion. What we explained to improve his shot was to increase his angle of release to the proper angle. In doing this, he involuntarily increased his initial velocity because of the increased arc length. This is represented by the image you can see here, where a low angle of release results in a lower arc and decreased chances of making the shot into the hoop. The agreed upon ideal angle is 45 degrees for a three-point shot, but depending on the distance from the hoop, that angle will vary a little. This is just one of the many examples of projectile motion in sports. and how changes in the components of projectile motion can determine victory.